Okay, welcome to Foundations Pre-Calculus Math 10 with Mr. Johns. Today we're going to do section 5.2, but we're going to start with a skill builder for 5.2. So the first thing we want to look at is evaluating algebraic expressions, and this is just substituting a number in for the variable. And so you can look through this example. I'm going to do 1a. So it says to evaluate each expression when x is equal to 3. And then they give me the expression 3x plus 4. So if x is going to be 3, I'll put in 3 for x in brackets. And this means 3 times 3 plus 4. And 3 times 3 is 9. We do multiplication before addition. And then 9 plus 4 will give us 13. You try 5x minus 7 substituting x equals 3. Another skill that we need in this section is to solve an equation to find the value of the variable that makes the equation true. So basically we just need to solve an equation. You can look through this one. 1a, it says 3x minus 4 equals 23. What we need to do is get x by itself completely. So to make minus 4 go to the right side, we're going to add 4 on both sides. And minus 4 plus 4 is 0. That's what we want. So just 3x is left on the left. 23 plus 4 is 27. And now essentially we're going to divide both sides by 3. So 3 over 3 is 1x, and that's what we want. And 27 divided by 3 is 9. So our answer here is x equals 9. Go ahead and solve 5x plus 7 equals 42. Okay, so on to section 5.2, and this is properties of functions. So there's lots of definitions and things we need to pay attention to and learn. The first big thing to learn is that the set of first elements of a relation are what we call the domain. So the first circle or the first column in a table would be the domain, and what they're related to are the second set of elements is called the range. And we often call this a function, which is a special type of relation where each element in the domain is associated with one element in the range. So nothing in the domain can be repeated. So I'll let you go through example 1 if you need some clarity. I'm going to go through check number 1 here. So for each relation below, I've identified the domain, which is the first set of elements, and the range, which is the second set. Then decide whether the relation is a function. And just to remind you, a function will only have, the domain can only relate to one thing on the range. So a relation that associates the number of tickets required for different rides at Galaxyland at the West Edmonton Mall is shown. And these are shown as ordered pairs. So you require 4 tickets to go on Cosmos, Space Derby, so on and so forth. So the domain is the set of first elements. And here we have 4. Whoops, I should list them increasing order. So we start with 3, 4, 6, and 7. And then we put these fancy brackets around them. The range is the second set of elements, and so this is everything that comes second in the ordered pairs, which is, I'll put my fancy bracket, Cosmos, Space Derby, Galaxy Twister, Mindbender, Galaxyland Raceway, and Balloon Race. So this is everything that's second in the ordered pairs. And so, two ordered pairs have the same first element, and this is 4, because 4 is related to Cosmos Space Derby and 4 is related to Galaxy Land Raceway. So this relation is not a function. Basically, nothing can be repeated in the domain. So here we have a circle diagram relating, that's another relation. So we have different instruments, and then they're related to different keys. So the domain is all the instruments. Alto, sax, clarinet, French horn, which I played for many years in high school, piano, and trombone. The range is everything in the second column. So B flat, C, E flat, and F. So if you look at the arrows from the domain, oh, sorry, this is an alto sax. It's not a, it's together, it's a single instrument, alto saxophone. If you look at the arrows, only one arrow comes from each instrument. And so this means that there's nothing repeated in the domain. And so because there's only one arrow from each element in the first set, this relation is a function. There we have it. So this table shows relating quarters to how much they weigh. And we call this first column, or the domain, often the independent variable. We can pick any number in this one and it'll just, we can use that number. We call the second set, or second column, often, or which is the range, often it's known as the dependent variable, because the number of quarters will affect how much weight we have. So this one's independent, it doesn't really matter how many quarters we have, but this one depends on how many quarters there are in terms of how much it weighs. So we say M is the dependent variable they're using for mass, and N is the independent variable which they're using for the number of quarters. So here's an example that you can go through to help you understand. I'm going to go through this check number 1, which this table shows the calories burned for various running times at an average speed of 8 kilometers an hour. So if I run for 5 minutes, I'll burn for 0.67 calories. 10 minutes, 1.34, and so on and so forth. It asks why this relation is a function. And if you remember, everything in the domain needs to have it can only be used once. So every time we run for more minutes, we're going to get a new amount of calorie burns. So why is this relationship a function? No two numbers in the domain are repeated. So identify the dependent variable and the independent variable. So the calories burned depend on the number of minutes running. And this is known as C, and this is known as N. So C is the dependent variable and N is the independent variable. The domain is everything in the left column, which is 5, 10, 15, 20, and 25. The range is all the numbers in the right column. 0.67. Oh, I better use my fancy brackets. 1.34, 2.01, 2.68, and 3.35. And there we have it. So based on those examples I've gone through, I would like you to do all of number 1, A, B, and C, all of number 2, and all of number 3. Tomorrow we'll finish this section and do the rest of our assignment.